Hey guys, today we're going to take a look at our final function for this section, and this is our 1 over x function. In my opinion, this is the trickiest function to wrap your head around. It's a little bit more confusing than the others, but we're going to break it down and see what we can do. Alright, so let's start off by graphing what this function looks like. So our 1 over x function, for our x values, we're going to use 4, 2, 1, 0, -1, -2, and -4. So what we do is, once again, we just plug in our x. So we would have 1 over 4. And that's actually where we stop. Our y is a quarter. It will be then a half. It'll just be 1. And then what we have is this. And if you're familiar with what 1 divided by 0 is, it's actually nothing. It's 0, and it's not actually possible. So if you put that into your calculator, you'll probably get something called error, or it won't give you an answer. So this tells us that there's actually no number there. And then -1 will get -1. We'll then have -1/2, and -1/4. So let's go about and graph these points. So to start off, when we're at 1, it's 1. Then when we're at 2, it's a half. When we're at 4, it's a quarter. Okay. Same idea in this negative section. We have -1, -1, -1. -2, -1/2, and then a quarter. So we're actually going to add a little bit more data to our sheet so we can better understand the shape of the graph. And what we're going to do is, when x is a half, or x is -1/2, what is y going to be? Well, let's see. If we have y is equal to 1 over a half, we flip and multiply. So it will be 1 multiplied by 2 over 1, giving us 2. And it's going to be -2 here. So that tells us that when we have a half, it's actually up at 2. And when we have -1/2, it's -2. So when we draw this graph, we're never actually going to hit 0. And that can be seen too from here. It's telling us that 0 is not possible for a 1 over x graph. So we get something called asymptotes. So 1 across each of the axes. Okay, so this dotted line just is a demonstration, a visual, for that nothing is going to actually touch that line. And if we connect all of our dots, we're going to end up with a shape, and this line is going to keep on going, and it's going to get infinitely close to 0 without ever actually touching it, like that. Same idea here. It's going to go and it's going to get closer and closer and never actually hit 0. Perfect. So this is just our y equals 1 over x. Now let's take a look at our transformations that can be done. So once again, we have our possible transformations. The first one is A, which is our stretch or compression. And this is a vertical. We have the way this actually works is this h is underneath that 1, so 1x minus h, and that's our translation, right or left. And don't forget, that's the opposite of what we think it's going to be. So if it's positive, our brain wants it to go to the right when it's actually going to go to the left. When it's negative, it's actually going to the right. This is our translation up and down. And then, just like all our other functions, a can be either positive, meaning no reflection, or it can be negative, which tells us there's a reflection over the x-axis. Okay, so this is going to be a little bit messier, but we're going to give it a shot and graph our different our different transformations. So let's start off with y is equal to negative 1 over x. Well, what we'll end up with here is we're reflecting it over this axis. And our asymptotes are not going to change, they're going to be in the exact same spot. But what will be different is we'll have 1 in this corner, like this, and 1 over here. So this one in purple is y equals negative 1 over x. Okay. Next up, let's take a look at y equals, and if you're wondering, well, where will the transformation be? Technically it's in front, but if I write it like 2 times that, this just multiplies. So how we'd actually write an a is like this, 2 over x. So that's our stretch of 2. And this is going to be very similar, but instead of over 1 up 1, it'll be over 1 up 2. Instead of over 2 up a half, it'll be over 2 up 1. It'll be over 4 up a half. So same idea though, it's going to go and it's going to reach infinitely close to that 0 line without actually touching. Same here. And then on the other side, same idea, instead of negative 1, it'll be negative 1, negative 2. Instead of negative 2 a half, it'll be negative 2, 1, and then negative 4 a half. Or sorry, negative 4, negative a half. So same idea, and you can see that it's been, in this case, stretched a little bit. So let's just finish this one off. So this is our y equals 2 over x. So this is where we see something a little bit different. So when we're doing transformations right and left, the other thing that's also going to be moving is our asymptote. So if I have y equals 1 over x, and let's say plus 3. So that's telling us it's going up 3. So what we're also moving is, currently the asymptote is sitting at 1. Instead, our new asymptote for this one we're about to do is going to be at 3. And the reason for this is because if you were to plug in 3, now you're going to have that inability, it's going to be over 0 and it's not going to work. Okay, and then same idea though, we're going to draw our graph. It will follow the same patterns for now, 1, 1, and get infinitely closer, except now it's all revolving around the new asymptote we have, which is at 3. Perfect, so this one is y equals 1 over x plus 3. And then last but not least, let's take a look at y equals 1 over x. And let's do plus 4. And this plus 4 you can see is actually underneath the 1 over sign. That's telling us it's that opposite of what we think situation. So it's going to go left 4. So what's moving this time is our y-axis asymptote. So let's redraw it on. So it's between this asymptote here and the one here. And then you're going to do the exact same idea, except with your different asymptote. And now our graph looks like this. So this is a little bit hard to see all of them because there's lots going on, but that's how we do our different transformations for a 1 over x function. So this is our final function for this series, so feel free to take a look at the other function videos and subscribe to follow along for other easy and short math videos.